So like I was saying, we don't always want to find all 6 things, and so these mathematicians from a long, long time ago, I don't remember exactly who, but they discovered and proved that if you can say all 3 sides of a triangle are congruent, then you can assume the angles are also going to all be congruent. So by just showing the sides, we can go ahead and skip the angles altogether and say they're congruent. Okay, but again, this is only triangles. So we abbreviate that with SSS. And what it looks like, because part of what you're going to have to do is look at pictures and identify which shortcut we're dealing with. Now these shortcuts are actually called postulates. That's the mathematical word for them. So we don't always like the word shortcuts, so this one we call it a postulate. So the side, side, side postulate says if you can show that all 3 corresponding sides are congruent to one another, then the 2 triangles are congruent. Our other postulate for today is called side, angle, side. We abbreviate it SAS. Sounds like what?
Like boats. You kept saying the SSS.
Like boats.
Right?
Names of boats.
Oh.
Like the SSR.
Gotcha. Like USS Arizona. Yeah. Gotcha. Okay, so side, angle, side. So in looking at the name, the name tells us exactly what we're looking for in the triangle. So we're looking for a side, another side, and then where does the angle have to be? Where is the word angle in the sequence? In the middle. So that means in our picture, where does the angle have to be? In the middle. So if we have 2 sides and the angle in between them congruent, then we can say the 2 triangles are congruent, meaning we don't have to worry about the other 2 angles or the other side. We can just look for these 3. Okay, this angle that's in the middle, it has a special name to it. It's called the included angle. And the reason I want to point that out is because in the directions of one of your questions, it's going to say identify the included angle. It's asking for the angle that's in between the 2 congruent sides. Okay? So what we're going to be doing is looking at pictures or diagrams of triangles, and we're going to be trying to determine if they're congruent, just like we did on, what was it, number 8, 9, 11, and 12, except now we're just going to look for either all 3 sides or the 2 sides and the angle in the middle. We're going to look for the shortcut as opposed to all 6 things. Okay, so our first picture, we're going to draw that same kind of quadrilateral as before. So 2 horizontal lines slightly off center and vertical lines connecting. And then this time I'm going to draw the diagonal from the top left corner to the bottom right. Yes, sir.
Is it SSS?
Okay, you're right. These are going to be congruent by SSS, but I want to know why you think it's congruent by SSS. So if you first look at what do you know from the picture. So what is something we absolutely know based on what's drawn in the picture? We know that GH is congruent to itself. Why do we know that? What property told us that? The reflexive property. What else do we know from the picture? GJ and FH. And we knew that because of the markings, right? We can also say that it was given to us in the picture. Okay, what else do we know based on the picture? JH and GF, because again they have markings, so we know that because of the marking or the fact that it's given to us in the picture. So did we list out 3 sides that we know to be congruent? Yeah, we have 1, 2, all 3 sides. So then we can say that triangle GFH is congruent to triangle. Now what would the other triangle, what order do we have to put the letters?
H.
So G goes with H. What does F go with?
J.
J. And then G at the end. And that would be because of the side, side, side postulate. Okay, does everyone see why that one was side, side, side? Yes or no? This is our third side here because of reflexive property. So we have 1, 2, and then the third side there. Chase?
Do we need to write out every single congruent factor, or is it okay if we just put what the postulate is based on like just the lines in general?
It depends on if it tells you that you need to prove it or explain it. Okay, so if it asks you to write a proof, did this make sense what we were when just listing it out and then what told us? Because this right here is all that there is to a proof. These are your statements, and this is our reason. This is why we were able to write it out. That's an informal proof right there, by writing what do you know and why do you know it. So if it asks you, so like on numbers, on the number 4 through 12, it says to explain your answer. So yes, you might need to give a short explanation. Do you need to write out like a proof like this one? No, maybe not, but you do want to give some sort of explanation. Okay? So it'll depend on what the directions ask of you. Okay, we're going to do another one. So this is number 2. I'll move this up a bit. Just realized that chain was right in the way. Okay, this picture is a little different. I'm going to start by drawing a slanted line, almost like I'm drawing a big arrow. And then from that middle point, I'm going to draw a horizontal line. And then I'm going to connect each endpoint with the endpoint of that horizontal line, so that it looks a little bit like a kite. So we have M, A, E, T, So does anyone think they know if these are congruent, just by taking a guess or what your gut tells you? Which reason? Side, 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 or side, angle, side, do you think? I heard side, angle, side. Okay, so let's list out what we know to see if we do in fact have side angle side. So what's something we know from the picture?
A and B are congruent to each other.
Say that one more time.
A and B, like right line.
These two?
Yeah.
Okay, so A and E is congruent to AE. Why? That's the reflexive. Okay, what else do we know based on the picture? TA and MA. And that was by the markings, or we say given. What else do we know? We wanted to try to use side angle side. What's missing? We have a side, a second side. What's the third thing we would need? Say that one more time, sorry. But that would give us a side. What else in the picture do we know that we haven't written about?
MEA.
Close, MAE. Remember the vertex always goes in the middle? So we have the two angles. MAE is congruent EAT. And that was, again, that was given to us in the markings, or we write given. So now, do we have two sides with an angle in the middle? Yes. Huh?
That would mean E and M and then E and T or something.
Yes, you're getting to a different kind of proof that we are getting to later in this unit. Because once we know, based on just these three things, we have enough to say the two triangles are congruent. So we can write MAE, triangle MAE is congruent, and then we would want to match up our like parts. So M matches with T, A will match with itself, and E will match with itself by side angle side. Once you know that the two triangles are congruent, then yes, you can now say that ME is congruent to ET and all that. And that's actually a type of proof that we're doing in next week or the week after. So you're just working a little bit ahead. Okay? Okay, so on your second assignment, the one you're going to do tonight, you are going to have some proofs. In fact, you have one proof. Okay? Normally when we write a proof, just so you guys know, we don't use the word marking, we say given. So wherever we see marking, that's not really a mathematical reason, we say given. So start trying to get yourself in the habit of that. Something else that we always do is we always start by writing out the given, and so reflexive properties should have probably come after. So we probably should have written like these two first, and this one should have been written down here. It's not incorrect, it's just convention says we tend to put the given first and then we do our other stuff. And we'll get there eventually where I'll be really hard about it, but for right now, if you can just do something like this and tell me a statement and why you can say it, I'll be happy.